Now let's do exercise. This question comes from the textbook on page 321. So we're going to practice two different methods to determine the optimal overbooking limit. So this is a question. Again, it's a hotel. It's a family-run hotel, and the room rate per night is $69. And nearby resort room rate per night is $119. So what happened is that when customer book the hotel, book the room, they pay $69. In case of overbooking situation, we are going to walk overbooked customer to a nearby hotel. The hotel is going to pay $119 to accommodate the customer. In other words, in this case, if in case of overbooking, the hotel will lose money. How much money the hotel will lose? The difference. The hotel will pay the difference between $119 and $69. So what? In other words, the hotel will lose $50. So based on this information, the room rate is $69. The nearby resort hotel cost $119. So we can calculate the two type of costs. So the opportunity cost is CU is $69. So for empty room, if we have empty room, it costs us $69. This is opportunity cost. On the other hand, if we oversell and everybody show up, it will incur an overbooking cost. So what is overbooking cost? So in this example, it's a little bit different compared to the example we just covered. In the previous example, the overbooking cost is given. It's a given information. We don't have to do any work. In this case, see, the question is presented in a different way. So it did not tell us what is actual overbooking cost. In other words, instead, the question says the nearby hotel cost $119. So the overbooking cost is the difference between $119, which is the room rate for the nearby hotel, and $69, which is room rate for this hotel, so which is $50. So in case of overbooking, the hotel manager will lose $50. Basically, the hotel has to pay the price difference to accommodate the passenger, the customer with the reservation. The table shows the data on the number of no-shows. So this table is a very simple table. We had 10 different observations. So basically, we observed the data for the past 10 days. So we had 10 different observations. We observed data for the past 10 days. So out of these 10 days, on 4 of those 10 days, we had 0 no-shows. In other words, everybody showed up. So out of 10 days, there are 3 days when we had 1 no-show. The 1 customer did not show up. So out of these 10 days, on 2 days, we had 2 no-shows, and on 1 day, we had 3 no-shows. So altogether, it's 4 plus 3 plus 2 plus 1, 10 days. So we had 10 different observations. So this is given information. So based on this, we need to know the probability. So how likely we're going to have 0 no-show, 1 no-show, 2 no-shows, 3 no-shows. So this is the frequency. We need to convert frequency into the actual probability. First of all, we have 10 different observations. So we just do the sum up. So 4 plus 3 plus 2 plus 1. So we observe data for the past 10 days. So out of these 10 days, on 4 of those 10 days, which in other words, 4 divided by 10, 40% or 0.4. So with probability 0.4, we have 0 no-show. So out of these 10 days, on 3 days, so 3 out of 10, so 0.3. So with probability 0.3, we had 1 no-show. So out of 10, we had 2 days, 2 out of 10 days. In other words, 0.2 with probability 0.2, there were 2 no-shows, and with probability 0.1, we have 3 no-shows. So this is about converting frequency into probability. So now we have the 2 type of costs. We have the probability. We can apply the 2 methods to determine the optimal overbooking limit. So let's look at the first method. It's called cost analysis. So we use cost analysis. So we have to create a table. This is approach 1 or method 1, cost analysis. So the first column is the number no shows from 0 to 3, so 0, 1, 2, 3. The second column is the probability, corresponding probability. So we just calculate the probability. So 0.4, 0.3, and 0.2, 0.1. So these are copy-paste. The first two columns are copy-paste. Then we have to fill the table. We try each possible overbooking limit from the lowest one, 0, all the way to the highest possible overbooking limit, 3. So 0, 1, 2, 3. So these 4 numbers are identical to these numbers. So the overbooking limit are same as a number no show. So we try 4 different overbooking limits. So let's take a look. First of all, if we overbook by 0, if we overbook by 0 and there's 0 no show, overbook by 0, 0 no show, what will happen? This represents a perfect situation. I don't overbook, everybody show up, and my cost is at 0. There's no cost. What if I overbook by 0 and there's 1 no-show? 1 no-show means 1 customer did not show up. So 1 customer did not show up, that means I end up having 1 empty room. If I have 1 empty room, my cost will be opportunity cost, which is $69. So I end up having an opportunity cost of $69, 1 empty room. If I overbook by 0, 2 customers do not show up, I will end up having 2 empty rooms. So that represents twice the opportunity cost. So 2 times 69, I have $139, which is the opportunity cost, twice as much, because 2 empty rooms. If I overbook by 0, 3 people do not show up. 3 people do not show up, that means I'll have 3 empty rooms. That represents 3 times 69. In other words, $207 opportunity cost again. And let's look at second. What if I overbook by 1? If I overbook by 1 and 0 no-show, overbook by 1, 0 no-show, that means you will end up having a problem to accommodate all the customers. I overbook too much. Okay, everybody show up. I overbook too much, so I end up having overbooking cost. So what is overbooking cost? It's $50, because in this case, I will have 1 extra customer I cannot accommodate. I have to walk this customer to a nearby hotel. So it costs me the price difference, which is $50. So overbooking cost. What if I overbook by 1? There is exactly 1 customer no-show. In this case, this represents a perfect situation. So I don't have any cost. What if I overbook by 1 and 2 no-shows? In this case, I will have 1 empty room. So my cost is opportunity cost, $69. I overbook by 1, 3 no-shows. I end up have 2 empty rooms. So again, I will have opportunity cost, which is twice as much, so $138. Next, what if we overbook by 2? If I overbook by 2, 0 no-show, that means I will have to walk 2 customers to a nearby hotel. This is an overbooking cost, 2 people, for 2 people. So my cost is 2 times 50, which is $100. If I overbook by 2, only 1 people does not show up. And then I will have to walk, 1 customer to a nearby hotel. So it's an overbooking cost. It cost me $50. If I overbook by 2, 2 people no show, it's a perfect situation. Cost is 0. If I overbook by 2, 3 people no show, I will end up having 1 empty room. So I'll have an opportunity cost, which is $69. So of course you can do this for overbooking limit 3 as well. You can do the number, so it will be overbooking cost 150, overbooking cost 100, overbooking cost 50, and then the last one represents perfect situation, so no cost. So fill the table. And then we want to calculate the expected cost for each possible overbooking limit, which is 0, 1, 2, and 3. So first of all, let's look at overbooking limit 0. If we overbook by 0, what is the average cost? Or in other words, what is the expected cost? The expected cost is the cost 0 times corresponding probability, which is 0.4, plus 69 times the corresponding probability, which is 0.3, plus 138 times the corresponding probability, which is 0.2, plus 207 times the corresponding probability, which is 0.1. So we can do the math. We get $69. So the average cost or expected cost if we overbook by 0 is $69. We can also do this for overbooking limit 1. So what is the expected cost? Which is $50 times corresponding probability 0.4 plus 0 times 0.3 plus 69 times 0.2 plus 138 times 0.1. So you do the math, you get 47.6. You can also do this for overbooking limit 2, you get number 61.9. You do this for overbooking limit 3, you get cost, which is at $100. So now we have the expected cost for each possible overbooking limit. So next, we compare these 4 different costs, we pick the lowest one. So look at these 4 numbers. Which one is the lowest one? The lowest one, obviously, is a 47.6. So the lowest total cost is 47.6, which corresponds to an optimal overbooking limit of 1. So 1 is the optimal overbooking limit. So by doing the cost analysis, we can identify the optimal overbooking limit. So for this particular hotel, we should overbook by 1 room. Okay, sell 1 extra room. So if we have 50 rooms available, we should take 51 reservations. So this is method 1, approach 1, cost analysis. Now let's move to approach 2. We use critical fractal criteria. So before we practice, I would recommend you go back to look at the previous slide and look at the previous example, see how we did it. And go over the procedure that we can practice on this example. Take a few minutes. So for critical fractal criteria, we have 3 different steps. Step 1, identify opportunity cost and overbooking cost. So for this example, it's already there. The opportunity cost CU is $69, overbooking cost CO is $50. So this is easy. Step 2, we calculate critical fractal. This is also pretty easy because, as I said, you're going to use a formula. The formula will be provided during the exam. So it will be CU divided by CU plus CO. We plug in the right number. CU is 69, CO is 50. We do the math, we get 0.58. So step 3 can be a little bit tricky. So for step 3, we use a table. The first column is a number no shows from the lowest 0 to the highest 3. The second column is the probability for each possible no shows. So in this example, it's 0.4, 0.3, 0.2, 0.1. So first 2 columns are copy paste. Then we're going to look at each possible overbooking limit, starting from lowest one to the highest one, and we calculate the cumulative probability until the cumulative probability exceeds the critical fractal calculated in step 2. Then we stop. So we start with the first overbooking limit. So what is the first overbooking limit? What is the lowest overbooking limit? Is 0. Okay, 0. So when X is equal to 0, in other words, when the overbooking limit is 0, what will happen? So under what conditions? D will be less than 0. So look at all of these. D can be 0, be 1, 2, 3. But D can never be less than 0 because the smallest D is 0. It's equal to 0. It will be never less than We look at the conditions. D less than X. So D will never be less than X. So that means it will never happen. If it's never happened, that means the probability is 0. Then we can try the next overbooking limit, which is 1. So if overbooking limit is 1, in other words, if X is equal to 1, under what conditions? D will be less than X. Look at all these different D's. So which D will make D less than X? So obviously, only when D is equal to 0. When D is 0, X is 1, so D is strictly less than X. So what is that cumulative probability? So look at the probability, it's 0.4. So 0.4. Now let's compare. So does 0.4 exceed the critical factile identified in step 2? In this case, does 0.4 exceed 0.58? The answer is no. If the answer is no, we continue. If the answer is yes, we stop. Okay. So in this case, because the answer is no, we continue. So we try the next overbooking limit. So next overbooking limit is 2. So when overbooking limit is 2, in other words, when X equal to 2, we want to see under what conditions D is less than X. So look at all these different D's. So when does D when is D less than X? So when D is equal to 0 or 1. Okay, when D is 0 or 1, D is less than X. X is equal to 2. So we look at the cumulative probability. So cumulative probability, we add up all the probabilities for 0 and a 1, so which is 0.4 plus 0.3, we got 0.7. So we have 0.7. Now let's compare. Does 0.7 exceed the critical factile, which is 0.58? 0.7 compared to 0.58. Does 0.7 exceed 0.58? The answer here is yes. Okay, the answer is yes. If it's yes, we stop. So we stop here. As I said, 0.7 exceed 0.58, but we really want to find out the largest overbooking limit that is less than the critical factile. That's why we say as soon as we stop, we go back to the previous step. So we go back to the previous step, which is a overbooking limit 1. So this is the optimal overbooking limit. So the optimal overbooking limit is not 2. We have to go back to the previous step. So whenever we identify a cumulative probability that exceeds the critical factile, we stop, and we also have to go back to the previous step. So from the previous step, we can identify the optimal overbooking limit. In this case, the optimal overbooking limit is 1. So you can see the answer is same as the answer we identified using approach 1. So either approach 1 or approach 2, you will be getting exactly the same answer.